Okay, everyone, let's begin. March 2026, paper 3-2. This is what we are doing today, inshallah. We will do this full paper. Since the marking scheme is not available, I would highly recommend that you would do the calculations alongside me. Let me know if there's any careless error at any point. I will also try that I do the verification sat as well with each question. Wherever we can verify quickly, we will do that, inshallah. Okay. So you know how to do this in the exam as well. All right. March 26, paper 3, variant 2. This is A-level maths. Let's begin. Achha, we need to solve this equation. Question number 1. 4 into 2 raised to the power x plus 2 minus 5 into 2 raised to the power 2 minus x, that is equal to 3, giving an answer correct to 3 significant figures. Now, how do we solve this equation? Can we take log on both sides? Can I take log on both sides? Is that going to work? Taking log on both sides, is that going to be a good idea? Yes, no? What do you think? Generally, in such questions, since x is in the power, we could we generally we take log on both sides so that x comes down, right? But in this case, the problem is we have this minus sign in the middle. So taking log on both sides, that is not going to help because we will end up getting minus inside log, and there's no way to simplify that then. So what do we do in such problems? What do we do? What do we do in such problems where we have plus minus sign between the terms and x is in the power? Can anyone remind me of the method that we use in such problems? We have to use substitution, right? We have to use substitution. We will do it by using substitution. Now, what substitution do we use? We want some number raised to power x that we will substitute with another letter. Now, what number is x coming in the power of? It's 2, right? 2 raised to power x. That is what we can use for substitution. For that, we will need to separate these terms first of all. Now, how can we do that? 2 raised to power x plus 2, I can write that as 2 raised to power x into 2 raised to power 2. We can break it like this, right? Using indices rules, 2 raised to power x plus 2 is the same thing as 2 raised to power x into 2 raised to power 2. And then similarly, here as well, we have 5 into 2 raised to power 2 minus x. What I can do is I can write this as 5 into 2 raised to power 2 divided by 2 raised to power x. On the other side, I've got 3 as it is. So first of all, using indices rules, you write it like this. Now, what we can do is 2 raised to power x is appearing here, 2 raised to power x is appearing here. What we can do is we can use a substitution. We can say let some other letter, let u equals 2 raised to power x, and then this equation becomes 4 into 2 squared, that's 4 times 4, which is 16, 16 times u, minus 5 into 4, which is 20, minus 20 over u, that is equal to 3. This is the equation that you now need to solve. Okay, let's solve this equation now. Multiply the whole equation by u, and that gives you 16u squared minus 20 equals 3u on the other side. Let's bring 3u to this side, and that gives us a quadratic equation. 16u squared minus 3u minus 20 equal to 0. Just put this whole thing on your calculator. After inputting in the quadratic formula, minus into minus 3 plus minus square root of minus 3 whole squared minus 4 into 16 into minus 20 whole divided by 2 into 16. Do show this step, even though in paper 3 sometimes they get away. You do get away with not showing this particular step as well, but it's a good idea to make this habit. It doesn't take a lot of time, just writing this one step. Write down this one step, then you can write down the answers after that. What are the values of u that you're getting? After this point, you can do the calculation directly from your calculator, and that's okay. Use the equation solving function on your calculator, and that will be fine. Okay. Achha. Now, what are the values of u? U is 1.2157. This is one possible value of u that you're getting, and the other one, negative 1.0282. These are two possible values of u that we're getting. Okay. Walaikum assalam. Let's now put that substitution back. 2 raised to power x is equal to 1.2157 or 2 raised to power x is equal to minus 1.0282. Now, this is not possible. If you take log in both sides, you will get an error from this. So you say this is not possible. The other equation, if you take log in both sides, you can say ln of 2 raised to power x, that is equal to ln of 1.2157. X comes down there and it becomes x ln 2 equals ln of 1.2157. Divide ln 2 on the other side and that will give the value for x. You can see what that is. What's the value of x that we get? Can multiple people please do those calculations so we are not making any careless mistakes? 1.2157 divided by ln of 2, and that is giving me 0.281787. Now, in the question they're saying write down this number to three significant figures. This will definitely make you lose a mark if you don't round off in this case. Otherwise, they often do not penalize, but still the instruction is you should write three significant figures in general as well, so you should follow that. 0.282, that's the value of x that we're getting, and that's our final answer. Is my screen freezed for everyone? It is lagging. Screen is lagging a lot. It might be the air server that I'm using, maybe. Let me check that. Okay, can you see me making all of these random lines here or not? Okay, did it only happen for a few seconds or has it been happening since the beginning? Few seconds? Okay, all right. So I think there must be some temporary issue there. Hopefully it stays fine after this. Let me check the connection on the other device as well. Is it fine? Okay, this is the answer that we're getting. No, it's not necessary to show more steps than this. Uh, he might have said if you want an exact value, in that case, you need to show more steps. But if you don't want an exact value, this is enough. This is sufficient. Okay. Then you can write down the answers after that. Acha. Now, if you want to verify the answers, you can just put that back in the equation and see what you get. On the left side, 4 into 2 raised to power x plus 2, whatever was the answer, just put that here. Answer plus 2 minus 5 into 2 raised to power 2 minus the answer. And see what that gives you, 2.999, and that is almost the same as 3, and that confirms that our calculation is correct. Okay, let's move on. That was question number 1. Question number 2. Let's look at this now. Let's have a look at this. Diagram in vectors is not tested a lot in recent papers. That's what you're saying. That does not tell you anything because it is part of your syllabus and it is actually tested a few times at least in the recent papers. So you can't skip anything. Please don't skip any topic thinking or any particular concept thinking that it will not be tested. That's not a good idea. That's a very bad idea. You have to make sure that you know all the concepts in your syllabus. Okay, question number 2. Let's look at this now. On the Argand diagram, sketch the locus of the points representing z. Now, think about it. Modulus of z equals 9 and argument of z equals pi over 2, between pi over 2 and pi. Now, how can we do this? We've done this before. We've done this before in other recent papers as well. What does this mean? Modulus of z equals 9. What is this locus going to be? It's a circle. Modulus of z can be thought of as z minus 0, right? It's a circle with center 0. And radius 9. Okay, so that's one thing. So there's azan going on here. I have a few seconds break and then we'll see. Can you guys see my screen again? Yes. Now I can see it on my other device as well. Let me see if it is still lagging. Achha, so if you're sending me any message, make sure that you send it to the host account. Send it to the host account or just send it to everyone. That will be safer. If you're sending a direct message, a private message, send it to the host account. Okay, the one that has the video on. Otherwise, I'll not be able to see your message. Okay, chale. So we were given the complex number z satisfies this equation. Modulus of z is equal to 9. That means we have a circle with center at origin and radius 9. Now the circle should be drawn with a compass. It should pass through these points 9, minus 9, 9, minus 9. Achha. Now they're saying another condition is the argument of z is between pi over 2 and pi. So what we can do for that is we can make a line like this from the origin 90 degrees, pi over 2 radians. That's going to look like this. Pi over 2 radians. This will be one line, right? And then another line, which is pi radian line. What is that going to look like? That line will be like this. Now, you can be anywhere between these two. What that means is this is the region that satisfies both of those inequalities. Now, this is one way of doing this, but in the recent marking schemes, the way they actually show this is rather than shading that part of the curve, what they do is they just show the part that is valid. So they don't have anything else showing there, and they just do something like this. So that's what you should do ideally. This is the region this is the curve, this is the arc that satisfies both of those conditions. Its modulus is 9, its distance from origin is 9 units, and the angle is between pi over 2 and pi. This angle is pi over 2, and this angle is pi. So we'll make a line make a curve like this. So yes, you should erase the rest of the circle. This will be locus of the points representing z. Okay. In this case, since we don't have an area as such, it's just all the points on this arc. So it's a good idea to just not shade any region. Instead of that, just show this arc and erase everything else. Okay. Now they're saying on the same diagram, sketch the locus of z conjugate plus 3. What is this going to be now? Z conjugate plus 3. Z conjugate plus 3. What is z conjugate? When we find conjugate of something, what happens is the imaginary part flips, and we have seen questions like this in recent past papers as well, where they ask you for the geometric effect of taking a conjugate of a complex number. What is that geometric effect? Reflection in the line x-axis. Why does that happen? Because the imaginary part flips. So if we were just thinking about z conjugate, that would look like this. That will be an arc like this. This would be z conjugate. It will be reflection of that in the x-axis. Okay. However, we also have a plus 3 there. What do we do about that? Plus 3 means in the real part, we are adding 3. What happens because of that now? When we add 3 to the real part, the horizontal axis represents the real part. What will happen would be this graph is going to move 3 units to the right side. Okay? The real part is going to increase by 3 units. So what happens is this curve is going to shift to the right by 3 units. So now it will be starting from -6 here. Erase the rest of it. It will be starting from -6 here and going up to this point, which is 3 and -9. So this is what it looks like now. You can draw this roughly like this. And you say this is the locus of z conjugate plus 3. Make sense to everyone? Isn't it a change in the imaginary part? Do we have iota with it? This is just 3, right? 3 is a real number. 3 is a real number. Okay, no problems with this. Let's move on now. So plus 3, that's the real part. We are going to add 3 to the real part, right? So that means it moves to the right. It moves to the right. And yes, you should be making this arc using a compass. Use a compass for making this arc. Put your compass needle at 3 here, open it 9 units, and make an arc like this. Okay. Shut up. Question number 3. Another saying, find the exact value of this thing. Integral of 3 sine x into sine 2x with limits from pi over 4 to pi over 3. Give an answer in this form. How do you integrate this thing? Sine x into sine 2x. These are two trigonometric functions multiplying. Is integration by parts going to help? Is integration by parts going to help in this? Generally, no, because remember, trigonometric function, it doesn't get simpler. Derivative of sine x is cos x, integration of sine x is minus cos x. So it is just going to keep changing from one function to another. Loop method might work in this. You'll have to try, but sometimes it works, sometimes it doesn't. What else can we do with such problems? When you have two trigonometric functions multiplying, that method is used quite a lot. The extended power rule that we discussed. If we have anything raised to power n, and you have the derivative of the expression inside multiplying outside, then the integration of this, what is that given by? This thing as it is, we add 1 to the power and divide by the new power. Okay? This is what we may have to use. Now, let's simplify this first of all. We have sine x and sine of 2x. Two different angles. We could simplify it like this. 3 sine x into 2 sine x into cos x. Right? Sine 2x can be written as 2 sine x cos x. Now, let's simplify this further. It becomes 6 sine square x, which we can write as sine x whole squared into cos x. And now you see it is exactly that form where you have some expression inside brackets and there's a power on top of that. You have this expression inside, there's a power on top of that, and we have the derivative of that multiplying outside. It's exactly this form. We can just use this directly. And that will give us 6 constant as it is. Integration of this thing, what is that going to be? Just sine x whole raised to power 3 divided by 3. That's your integration. Input limits now. Limits are from pi over 4 to pi over 3. Now we just have to input those limits. Okay, input the limits 2 into sine x whole cube. That means 2 into sine pi over 3 whole cube minus 2 into sine pi over 4 whole cube. Now, since we want an exact answer, do not write down the answer directly. You have to show working for this. You need to show working for this. Do not write down the answer directly. Okay. Sine pi over 3. Put this on your calculator. Your calculator will give you some number for this. I think it is under root 3 over 2. Please confirm this as well. You can just find it from your calculator and that's okay. Sine pi over 4, that is under root 2 over 2. And then we have whole cube on top of that as well. So let's simplify this further. What does this become? Under root 3 whole cube. What can you write that as? Under root 3 whole cube. Under root 3 whole cube, we could say that is under root 3 squared into under root 3, right? And that becomes 3 under root 3. Okay? Under root 3 whole cube, that can be written as 3 under root 3. So in the numerator, we have 3 under root 3. In the denominator, 2 cube is 8. And similarly, here as well, under root 2 whole cube, we can write that as 2 under root 2. In the denominator, we've got 8. Simplify this. This gives you 4. This also gives you, this gives you 2. And what are we left with? 3 over 4 under root 3 minus 1 over 2 under root 2. They wanted you to give your answer like this, under root p under root 3 plus q under root 2. That's exactly the form that we're getting here. P and q were supposed to be rational numbers. That means some fractions. And that's our final answer. Yes, you're right. You could use substitution as well. You could use substitution as well. The substitution you could use could be, you say u equals sine x, use that substitution, right? Like we used to do for odd powers of sine x, cos x. You could do that as well, and that will also work. Is that okay? ठीक है. IBP integration by parts. Okay, I had to think about it, what that means. Integration by parts won't be simplifying the rectangle because it's not large trying to do this. When you have two trigonometric functions, okay, so remember isolate. Why do we use isolate to decide between u and v dash? We say whatever is on the left side, that should be u, whatever is on the right side, that should be v dash. Because we want u to be something that simplifies after differentiation. We want u to be simplified after differentiation. Now, I is inverse trigonometric. That means tan inverse. So tan inverse, when you differentiate that, when you find u dash of that, that becomes something simpler, 1 over 1 plus x squared. So that in the next step of integration by parts, you will have a simpler integral. Similarly, when you have log, u equals ln x, that becomes 1 over x. When you have algebraic, u equals x cube, for instance, or x squared, for instance, it becomes simpler after differentiation. It gives you 2 times x. When you have t or e, however, t and e, when these two functions come together, then we have a problem because they don't become simpler after differentiation. So integration by parts, we are going to get stuck at some point if you're using that. So if you have both trigonometric functions, that's going to be a problem because they will not become any simpler. If we say u is equal to sine x, in this case it was sine x, let's say, and v dash was sine 2x. Now what is u dash going to be? U dash is cos x, and v, that is minus cos 2x over 2. Now the next integral is again going to have a product and you're again stuck. So when you have two trigonometric functions multiplying, integration by parts generally is not going to be helpful. The loop method works sometimes, but this is more efficient. You can just use this. The loop method is going to be helpful when you have one trigonometric and one exponential. So for example, if you had something like this, e raised to power x into sine x, and you wanted to integrate this. Now in integrals like this, you can use that loop method that we discussed to say this is I equal to this, and then you simplify this using integration by parts. At some point, you will end up getting the same thing again, and then you can write that as I, and then you can evaluate whatever I turns out to be equal to. Okay? ठीक है, चलें, let's move on. So when you have two trigonometric functions, you will often have to do this. Okay, and this is happening recently in the last 2-3 years. You will see at least 2-3 questions like this where you have trigonometric functions multiplying like this. This is how you would do it. You can verify your answer quickly at the end as well if you want, if you have time, of course. We are already late, I say, but let's just do it anyway. So if you input this integral in this, 3 into sine x into sine of 2x, integration with limits from pi divided by 4 to pi divided by 3. Just input those limits. What do you get from this? 0.5919. Keep that in mind or just write it down somewhere. It's 0.5919, 3 over 4 into under root 3. The answer that you're getting, I'm just inputting that here, minus under root 2 divided by 2. And that's coming out to be the same number, and that confirms that your answer is correct. For a 4-mark question, it will probably be too much effort. You can do it at the end of the paper once you're done with the rest of the questions. Chale, let's look at this now. Now we've got binomial. The coefficient of x cube in this expansion, 1 minus ax whole raised to power 2 over 5, that is 1. Coefficient of x squared is 1. X cube, sorry, that is 1. Find the value for a. How do we do this? Let's expand it. Let's expand and see what we get from this. 1 minus ax whole raised to power 2 over 5. Now input in the formula. What's the formula? 1 plus x whole raised to power n, that is equal to 1 plus nx plus n into n minus 1 divided by 2 factorial. It's given in the formula sheet. X squared plus n into n minus 1 into n minus 2 divided by 3 factorial x cube. Okay, that's the formula that's given in the formula sheet. Apply the formula, see what you get from this. 1 plus, now, what term are we really looking for? The coefficient of x cube, right? Do we need the rest of the terms in the next part? Coefficient of x power 4 in that expansion. Will we need that x into x power 4? Okay. So since in the first part, we are just looking for coefficient of x cube, what we can say is, where are we going to get x cube? X cube is going to come in this term. So we can ignore the rest of the terms. We'll see in the next part if we need any of them. But for now, we just focus on this term, right? Ignore the rest of the terms. N into n minus 1, that means 2 over 5 into 2 over 5 minus 1 into 2 over 5 minus 2. Whole divided by 3 factorial into minus ax. Do not forget the negative sign with that. Minus ax whole cube. Right? That's the term that we are concerned about. Just focus on this term. Ignore the rest of them. Okay? Achha. Now, let's simplify. Put this whole thing on your calculator. 2 over 5 into 2 over 5 minus 1 into 2 over 5 minus 2. Okay. Divided by 6. And that will give you some number, 8 over 25. And then you have this negative sign from inside as well. So it will be negative 8 over 25. Negative 8 over 125, a cube x cube. Now they told us the coefficient of x cube is equal to 1. That means this thing should equal 1. So we just equate it to 1, and that will give us the value for a. Let's see what that turns out to be. Minus 8 over 125 a cube equals 1. A cube equals minus 125 over 8. Take cube root of that, and that will give you minus 5 over 2, or 2.5 minus 2.5. Right? Cube root of 125 is 5. Cube root of 8 is 2. That's 5 over 2, which is 2.5, and that's our final answer. Okay, that's what we were looking for. A is negative 5 over 2 or negative 2.5. That's the first part. So now they're saying it's very similar to P1 binomial now, the next part. They're saying find the coefficient of x raised to power 4 in this expansion. Now, first of all, in problems like these, we have to figure out which terms are we looking for? Which terms are we looking for? This is x, right? What will we need to multiply x by to get x power 4? X cube, right? That's one term that we need. And now this is interesting because I've not seen this in any paper before. What do we multiply 1 by to get x power 4? X power 4. Generally, they do not require you to expand any more than this. But in this case, they want you to expand up to x power 4 now. So from that previous expansion, you also need the x power 4 term. These are two terms that you need from that expansion. Now, the x cube term we already have, right? X cube term we already have. Let's just find x power 4 term and see what that turns out to be. So now we know the value for a, right? The value for a is 2.5, negative 2.5 or negative 5 over 2. We can input that there. So this expression would become 1 minus a x. That means it is going to be 1 plus 5 over 2 times x. Whole raised to power 5 over 2. 2 over 5. That's the expansion that we had. Let's do this expansion. We know the coefficient of x cube is 1, so we have 1x cube. What about x power 4 term from this? Now, this is not given in the formula sheet. This is not given in the formula sheet. Normally, they don't ask you to expand it to x power 4, right? Only up to x cube. Acha. Now, x power 4 term is not given in the formula sheet, so you have to look at the pattern. What's the next term going to be after this? Looking at the pattern, next term is going to be n into n minus 1 into n minus 2 into n minus 3 divided by 4 factorial into x power 4. We have to input values in that now. Okay, let's input values in that. Is my screen fine now, by the way? Is it still lagging for anyone? No? Okay. Sorry. Let's input values in this n, which is 2 over 5 into n minus 1, 2 over 5 minus 1 into n minus 2, 2 over 5 minus 2 into n minus 3, that's 2 over 5 minus 3. Whole divided by 4 factorial into x raised to power 4. That means 5 over 2 x raised to power 4. 5 over 2x whole raised to power 4. Okay. Now we can simplify this, put this whole thing on a calculator. Apart from x, put the whole thing on a calculator, see what you get. So I did some part of it before. Okay, it's not going back anymore. It is 2 over 5 and 2 over 5 minus 1 and 2 over 5 minus 2. Now we add 2 over 5 minus 3 to this. And then in the denominator, we have 4 factorial, which is 24. 4 factorial multiplied by 5 over 2 whole raised to power 4. Please confirm this calculation as well. I'm getting minus 13 over 8 from this. Minus 13 over 8x power 4. Okay, that's this term that we're getting. Now, these were the two terms that we needed from that expansion. We ignore the rest of the terms. Now we can do the multiplication 2x plus 1 into x cube minus 13 over 8x power 4. How will we get x power 4? X power 4 will be when we multiply 2x with x cube and 1 with minus 13 over 8x raised to power 4. These two multiplications are going to give us x power 4. Let's see what we get from this. 2x into x cube, that is 2x raised to power 4. 1 into minus 13 over 8, that is minus 13 over 8x raised to power 4. Put this on a calculator now, and that should give you 3 over 8 x raised to power 4. They asked you for the coefficient, so you can write the coefficient of x raised to power 4, that is 3 over 8, and that is what we were looking for. Minus 13 over 8 is the final answer. Acha, from this, okay. Is this clear to everyone? 3 over 8, is that what you're getting? Right? Minus 2.875. You're getting something different. Has somebody else tried this as well? Has somebody else done this calculation? Okay, all right. ठीक है. Let's move on. For an A and AS, it really depends on whether you're taking M1 or S1. Depends on that because M1 was hard. Generally what happens is, from what I have seen, one of P1 and P3 is difficult and the other is easier. And one of M1 and S1 is difficult and the other is easier. So you might get a relatively easier S1, but there's no surety, of course. But that's what I think is the pattern. State the set of values of x for which this expansion is valid. Now, when is this expansion going to be valid? 1 plus 5 over 2 x whole raised to power 2 over 5. That's the expansion that we have done. All we have to do is whatever is the second term, whatever is the second term, you say modulus of that, that has to be less than 1. So you say 5 over 2x, its modulus that needs to be less than 1. Now take these numbers to the other side and that gives you modulus of x. That should be less than 2 over 5. That's the condition for that expansion to be valid. ठीक है. Does that mean you might get an easier P3? P1 was fairly easy as far as I've heard. So if P1 was easy, then P3 may be hard. Yeah, so my expectation would be that P3 will be a bit difficult. S1 might be easier. यहाँ सारे easy papers leak हो रहे हैं ये तो है. चलें, let's look at the next one. Question number 5. Achha, now it's given that z is equal to 3 plus lambda iota divided by lambda plus 2 iota, where lambda is the real constant. Find the value of lambda for which argument of z is equal to this. Okay, so we find the argument of this complex number z, and we put that equal to pi over 4, and that will give us the value for lambda. How do you find the argument of this number? We would have to simplify this first, right? We have to simplify this. Let's simplify this first, and then we will try to find the argument. We can say 3 plus lambda iota divided by lambda plus 2 iota. We can multiply and divide by the conjugate of the denominator. So multiply and divide by lambda minus 2 iota. Now, the numerator, what's that going to be? 3 plus lambda iota into lambda minus 2 iota. In the denominator, it's a plus b into a minus b. So that becomes lambda squared minus 2 iota whole squared. ठीक है. Now 3 into lambda, that's 3 lambda. 3 into minus 2 iota, that is minus 6 iota plus lambda squared iota minus 2 lambda iota squared. Okay, that's the numerator. What about the denominator? In the denominator, we've got lambda squared minus 4 iota squared. Let's simplify this. In the numerator, we have 3 lambda minus 6 iota plus lambda squared iota minus 2 lambda iota squared. That is going to become plus 2 lambda. In the denominator, we have lambda squared plus 4. Now, write the real part separate, imaginary part separate. 3 lambda plus 2 lambda, that will become 5. So we can say 5 over lambda square plus 4. That's the real part. And then the imaginary part, the terms that have iota in them, we could say they are minus 6 plus lambda squared divided by lambda squared plus 4 times iota. This is what z simplifies to if we separate the real part and the imaginary part. Is that okay? Any issues with this? 5 lambda होएगा 5 lambda, yeah, in the numerator. ठीक है, अच्छा. Now that we have simplified this, they have told us the argument of z is pi over 4. Now, which quadrant is this in? It is in the first quadrant. Keep that in mind. It's in the first quadrant, such that this angle is pi over 4. Now, with angle pi over 4, real parts and imaginary parts, they're equal to each other, right? But you can just input in the formula as well. What's the argument going to be? It's in the first quadrant, so whatever is the basic angle, that's the argument. So we can say argument of z, that must equal tan inverse of imaginary part divided by the real part. Okay, that will be a bit too complicated fraction. Let me just write it down anyway. Minus 6 plus lambda squared divided by lambda squared plus 4 whole divided by 5 lambda divided by lambda squared plus 4. Okay, so what I've done is I've divided the imaginary part with the real part. Now this must equal the argument that they gave us, that's pi over 4. So this should equal pi over 4. Now what happens is lambda square plus 4, lambda square plus 4, they get cancelled. Tan inverse goes to the other side, becomes tan pi over 4. On the left side, we're just left with minus 6 plus lambda squared over 5 lambda. On the right side, it becomes tan pi over 4. Tan pi over 4, put this on your calculator, that will be 1. So we have 1 equal to minus 6 plus lambda squared over 5 lambda. And again, we get a quadratic equation, lambda squared minus 6, that is equal to 5 lambda. Lambda squared minus 5 lambda minus 6 is equal to 0. Now, how do we solve this quadratic? There was another part to this as well. Where did that disappear? Okay. Lambda squared minus 5 lambda minus 6. We have to factorize this. Lambda squared, we can say there are two factors, lambda 6 and 1, right? So minus 6 and plus 1. Lambda minus 6 and lambda plus 1. These will be the two factors that we get from this. And lambda is either equal to 6 or lambda is equal to negative 1. These are two values of lambda that we're getting. Now the question said find the value of lambda. That's a singular. So that means there has to be only one answer. We're getting multiple answers. That means one of them is not going to be possible. One of them is not going to be possible, right? Now, how do we ignore one of them? We know the angle is supposed to be acute, so we are in the first quadrant. We are in the first quadrant. In the first quadrant, that means the real part should be positive and the imaginary part should be positive. So we can just check if any of them is giving us maybe a negative real part or a negative imaginary part. Let's check for that. This is lambda squared, this is lambda squared. If we put minus 1, however, what happens is the imaginary part here becomes negative. The real part also becomes negative with negative 1, right? Both parts become negative. That means it can no longer be in the first quadrant, then it will go in the third quadrant if the real part is negative and the imaginary part is also negative. So for that reason, we would have to ignore lambda equal to negative 1. We'll say this is not possible, and the only possible value of lambda, therefore, is lambda equal to 6. Whenever you get multiple answers, always go back to the question statement and see if all of them are going to be possible or not. Okay, so in this case, negative 1 was not possible. Any issues with this? Any problems, anyone? Lambda is wavelength. अच्छा इसका second part जो है ना, that is missing from here. Let me copy that. When lambda has the value found in part 5a, find the exact value of modulus of z, making our method clear. Now, once we have this value for lambda, this was the z value that we were getting, right? After simplification, we could just use that, input lambda equal to 6 in this, and then find modulus from this. Input lambda equal to 6. What do you get? 5 into 6 divided by 6 square plus 4 plus minus 6 plus 6 squared divided by 6 squared plus 4 iota. What does this simplify to? Can anyone tell me? 5 times 6 is 30. 30 over 40. That will be 3 over 4, right? Please confirm this. This is 30 over 40 as well. 3 over 4 minus 3 over 4 iota plus 3 over 4 iota, right? Yeah, that looks okay. What about the modulus of z now? Do not write down the answer directly. Show the step. 3 over 4 whole squared plus 3 over 4 whole squared, and then take square root of that. And that will give you the modulus. What's the value for modulus that you're getting? What's the modulus value? What's the modulus value? Has anyone done this? 0.75 squared plus 0.75 squared. Square root of this, and that is, do they want an exact answer? Yes. Achha, since they want an exact answer, we actually should show further working as well. We'll say this is 9 over 16 plus 9 over 16, and that becomes 18 over 16. And then we could say 18 can be written as 3 under root 2 divided by 4. Yeah, that's what we were getting, right? 3 under 2 over 4. And that's your final answer. Whenever they ask you for exact values, make sure to do it step by step. Do not skip any working in that case. ठीक है. All right, chale. Let's move on to the next one. Question number 6 now. Question number 6. Let's try this now. Okay, the polynomial 2x raised to the power 4 plus ax cubed plus so on, that is denoted by p of x. It's given that this is a factor of p of x, find the values of a and b. Now, how do we do this? This also looks like some complicated long division now. It's not a linear factor. That means we cannot use remainder theorem, right? That will not work. Remainder theorem is not going to work. So what do we do then? We have to use long division. Use long division, find the remainder. If the remainder turns out to be 0, in fact, you will put the remainder equal to 0, and that will give you the values of a and b. Let's do this. Let's start with the division process. We have 2x raised to the power 4 plus ax cubed plus 4x squared plus bx minus 3. Divide this by x squared plus x plus 1. What do we multiply x squared by to get 2x raised to the power 4? 2x squared. 2x squared into this whole thing. What is that going to be? 2x raised to the power 4 plus 2x cubed plus 2x squared. Change the signs. It becomes minus, minus, minus. This gets cancelled. Now, in the next step, make sure that you're writing it exactly like this. Coefficient of x cubed, you need to write it together like this. So a minus 2 whole times x cubed. This is how you must be writing this coefficient. Do not write down the term separately, ax cubed minus 2x cubed. That will make you do errors. Okay, write this whole thing as a single thing like this. Okay. Achha, what about this now? 4 minus 2, that will be 2x squared. And then plus bx minus 3. Okay. Achha. What next now? What do we multiply x squared by to get a minus 2 whole times x cubed? A minus 2 whole times x, right? Multiply this with the whole thing. What do we get? A minus 2 whole times x cube. Now you have to be a bit careful. It's very prone to careless errors, this working. So slow down a little if you need to. Now a minus 2 whole times x into x, what's that going to be? A minus 2 whole times x squared. Okay, again, write it inside brackets like this. Next, a minus 2 whole times x into 1, that will be a minus 2 whole times x. Okay, now change the signs again. This becomes minus, minus, minus. This whole term gets cancelled. Now 2 minus a plus 2. What is that going to be? 2 minus a plus 2. That's 4 minus a, right? So these terms, when we add them up together, they will give us 4 minus a whole times x squared. Okay, so 2 minus a minus 2, that becomes 2 minus a plus 2, which is 4 minus a. So 4 minus a whole times x squared. Okay. Next, b minus a plus 2. We will have to write it as it is, b minus a plus 2 whole times x and then minus 3 outside. Now again, what do we multiply x squared by to get 4 minus a whole times x squared? We multiply it by 4 minus a, right? 4 minus a into this whole thing now. What does that give us? 4 minus a whole times x squared plus 4 minus a into this, that will be 4 minus a into x, and then 4 minus a into 1, that is just 4 minus a. Okay. Again, it's important to write down this number in brackets like this so that when you put negative sign, you remember that this negative is going to be with the whole thing. Okay. Now we change the signs again. This becomes minus, this becomes minus, this becomes minus, this gets cancelled. Now let's do the subtraction. B minus a plus 2. It's a good idea to write it down so you don't do any careless errors. B minus a plus 2 minus 4 plus a. Minus 4 plus a. What does that simplify to? A and a get cancelled. We're just left with b minus 2. So that's what you write down there. B minus 2 whole times x. And then this last term, what is this going to be? Again, you can write it down this on the side. Minus 3 minus 4 plus a. What does that become? A minus 7. So we've got a minus 7 as the constant term. This is what we're getting. Now, they said it's a factor. This thing is a factor. If it's a factor, then that means the remainder must be equal to 0. This is the remainder, right? We cannot continue with the division anymore. The remainder must be 0 no matter what the value for x is. What that means is the coefficient of x must be 0. So 0 in this case, we would say is 0x plus 0. The x term must be 0 and the constant must be 0. So you put both of them equal to 0 individually, put b minus 2 equal to 0, and you put a minus 7 equal to 0, and that will give you b minus 2 equal to 0. The value for b turns out to be 2, and a minus 7 equal to 0, and the value of a turns out to be 7. These are the values of a and b that we get if this is a factor. Any issues with this? Musa, did you actually do this yourself or not? Or are you just watching me do it? You can do yourself, of course, you can, but why are you not doing it right now? साथ साथ करें ना, इंशाल्लाह उसके लिए एफर्ट करनी होगी ना. Okay, those of you on YouTube, what you can do is you can maybe pause the video for a minute or two and then attempt the paper and then watch in 1.5x the solution. That might be a good idea as well if you have not attempted the paper beforehand. Okay. Hence, show that x plus 3 is a factor of p of x. Now, that's straightforward. Now that you know the values of a and b, you can say the polynomial that you had is 2x raised to power 4 plus ax cubed, that means plus 7x cubed plus 4x squared plus 2x minus 3. Now, that will also be a confirmation of your previous answer. If it does turn out to be a factor, that means that the previous part was correct. So now, how do you show this is a factor? Just put x equal to negative 3, right? You use remainder theorem. Equate it to 0, the value of x that you get. Input that in the polynomial. 2 into minus 3 whole raised to power 4 plus 7 into minus 3 whole raised to power 3 plus 4 into minus 3 whole squared. You have to show this working. You have to show this working where you're inputting the value x equals negative 3. A lot of very good students as well, what they end up doing in the exam is they would do something like this. Put x equal to negative 3 and then they say it turns out to be 0. That is not acceptable. They deduct marks for this. They deduct marks for this. Make sure that you don't do it like this. You have to input values. You have to input values, otherwise you'll not get full marks. So show this step, and then you can see if that indeed is equal to 0 or not. Can somebody check this? What do we get? 2 into 81 minus 7 into 27 plus 4 into 9 minus 6 minus 3. And that is turning out to be 0. And that confirms that x plus 3 is a factor. ठीक है. If the quadratic factor is something we can solve, can we find x values in the factor, put those in the polynomial? Yes. So this only works in case it's a factor. It only works in case it is a factor, not if they give you some remainder. Then it will not work. If the quadratic expression that is given, that's a factor, and it can be factorized. For example, if they tell you x squared plus 7x plus 12, this is a factor of some polynomial. You could say this can be factorized to x plus 3 into x plus 4, which means x plus 3 is a factor and x plus 4 is also a factor. So in that case, you could use remainder theorem as well. Input x equal to negative 3 in this, input x equal to negative 4 in this. You'll get two simultaneous equations. You could solve those two simultaneous equations. So yes, that is possible. Okay. But in this case, we could not factorize this. So we won't do that. We have to use long division. ठीक है. Walaikum assalam. Let's look at the next one. That was question number 6, part B. Let me just confirm if there's no other part to this. This was 6, right? Yeah, okay. Let's look at the next one. Question number 7. Now they're saying by sketching a suitable pair of graphs, show that this equation ln x equal to cosecant half x has exactly one root in this interval. Okay, this is the question that I recommend that you should leave for the end of the paper. Do not do this in the middle of the paper. It's 2 marks, takes too much time. Don't do that. Don't do this question in the middle of the paper. Now, let's mark x and y axis like this. You'll have a blank page for this, blank space for this. You'll have to make your own lines. Now they're saying sketch the graph from 0 to pi. So negative part we can ignore. We just have to go from 0 to pi. Okay, 0 to pi. Let's break it down in the middle. That will be pi over 2. Break it down again in the middle. That will be pi over 4. Pi over 4 times 3. That will be 3 pi over 4. This is 3 pi over 4. You can break it down further to these points if you want. Okay. Now we can input this in the table function on our calculator. Let's input this in the table function. Make sure calculator is in radian mode. Table f of x equals cosecant half x. Cosecant means 1 over sine half x. Let's input this on our calculator. Ln x we will do separately, then you can also do it together. Let me just do it together. Ln x, let's just put that inside as well. Then we'll think about the asymptote for that as well separately. But for now, let's just input it as it is. 1 over sine of half x, let's say 0.5 times x. Okay, that's the other function. We input these two functions. Start at 0, end at pi. What about the step we generally take? Whatever the interval is, we divide that by 8, right? So pi over 8. That's what we can do. Pi divided by 8. Now, these are the values that we get. F of x is the log function. Let's ignore that for now. I'll draw the sine half x function because for log, we don't need so many values. Just a couple of values are enough. Let's look at the cosecant graph. You have values going from undefined at 0. In trigonometric functions, an undefined value means you have an asymptote. So you have an asymptote at 0 for cosecant. So there's an asymptote at 0. You can make dotted lines like this for that. Then it's 5 point something. Let me take a scale like this, maybe 2, 4, 6, 8, -2. 5 point something. Let's plot that somewhere around here. This first value, then the next value is 2.6. 2.6 maybe around here. Now, exact points are not important. What's important is the shape that you get from this. So just by plotting a few points, you'll understand the shape. It's going up all the way up to 1 at the end, right? The last value is 1. So it's stopping at 1 here. So what is the graph going to look like then? It's going to go like this. No, not like this. Something like this, right? So you'll draw a shape like this. You don't have to pass through all the points. You'll remove the points from there and just draw it like this. The important thing in this graph is the shape of the graph. It should be clear that there's an asymptote at the y-axis and the lowest point on the right side, that is at 1. This is an important point and the asymptote is important. These are two things that are important. The points that we plot, they're just to understand the shape of the graph. Okay. How will we do it without the calculator? We will not do it without the calculator. Why would you do it without calculator? How will you find values of cosecant without calculator? You have to memorize values for that. I don't recommend that. You have your calculator, just do it on that. Reciprocal trig functions, you should sketch them using a calculator. Okay, there's no need to memorize values. Achha. Now, what about the log function? What about the log function? Graph of ln x, that's a standard graph. You could actually remember the graph shape. You should remember the graph shape. Where is the important point for this graph? Important point is when this thing is 1, right? So x equals 1, that gives us y equal to 0 for the log function. That's 1 point, x 1 and y 0. Where is that going to be? Pi over 4 is 0 point something, right? Pi over 4 is pi divided by 4 is 0.785. So 1 will be slightly to the right of it. At 1, we've got 0. So the log graph is going to pass the x-axis somewhere around here. Where is the asymptote going to be? Asymptote is when this thing is equal to 1, equal to 0, sorry. This is the asymptote. Now that's the same asymptote for the cosecant graph as well. Now, what about the rest of the graph now? How is it going to look like? For that, we had that table function. Why did I get rid of that? Shoot. Okay, let's just put that again. Ln x start 0 and pi, we had that table already, right? So we could use that for a couple of other points. So at pi, I'm getting 1.14. At pi, I have 1.14. That will be around here, maybe. It's going to be slightly above the cosecant number, right? Because this was 1 at for cosecant. For log, it is 1.14. So it's going to be here. We have another point here on the x-axis. And you can see the other points. They're slightly reducing from this point to that point, and the asymptote is at x equal to 0. The graph is going to look something like this. It's going to come here like this. And here it's going to suddenly change its shape and become almost parallel to y-axis like this. This is the graph of the log function. You will label both of them. You'll say this is log of x, and the other one is cosecant half x. Okay. Makes sense, right? Any issues? Any problems, anyone? Okay. Verify by calculation, this root lies between 2.6 and 2.9. Now, how do we do that? We take all terms to one side, ln x minus cosecant of half x. We can write that as minus 1 over sine of half x. Take all terms to one side like this, first of all. That equals 0. Now, you could say this thing is f of x. We have fx equal to 0. Let's input those x values in this. Input 2.6 and then input 2.9 and see what values you end up getting from both of them. Has anyone done this? Has anyone done this? No? Can multiple people please do the calculation so we can verify quickly as well? We need to speed up a little. We have S1 today as well. ln of 2.6 minus 1 over sine of x over 2, which is 2.6 over 2. Okay. You can see what that is. This is turning out to be a negative number, minus 0.0823. Then you input 2.9 and see what that gives you. 2.9 gives you 0.0574. One value is negative, the other value is positive. So you write down the statement now. F of 2.6 and f of 2.9, they have different signs, or the signs are changing. That's the keyword. Signs are different or the signs are changing. You need to make sure that you write that. That is why the root lies between 2.6 and 2.9. Okay, that's what we had to prove in this part. That's a standard iteration part. Now they're saying use this iterative formula to determine root correct to 3 decimal places, give the result of each iteration to 5 decimal places. Now what starting point do we use? We have shown that the root lies between these two values. So use the midpoint, 2.75. That will be your starting point. X1 equals 2.75. Now put this on your calculator. 2.75, that's the starting point. E raised to power cosecant. Now, what is cosecant going to be? Let me write that down on the side. On your calculator, you'll do something like this. E raised to power 1 over sine of half. In place of xn, you put answer. And that's what you would input on your calculator. So e raised to power 1 divided by sine of half times the answer. All right, so x2. X2 is turning out to be 2.77175. We need 5 decimal places for each iteration. X3. 2.76584 X4. 2.76741 X5. 2.76699 X6. 2.76710. It's fairly stable now. It's rounding out to 2.767, right? You can stop here. The difference between these values is only 11 at the end, right? So it's not going to change much after this point. You're allowed to stop if you want. If you want to write a couple of more iterations just to be safe, you can do that as well. So if I write one more, the next one is 2.76707. But this is sufficient now. Write down the answer now to 3 decimal places. X equals 2.767, and that's our final answer. Okay, that was straightforward. Let's move on to the next question. This was question number 7 from this paper. Okay, 8. The variables x and y, they satisfy this differential equation. Variables x and y, they satisfy this differential equation. It's given that y is equal to 0 when x is equal to 0. Solve this differential equation to obtain an equation in x and y. Okay, so first of all, we separate the variables. dy is in the numerator on the left side, so y terms on the left side, and that will become y over y plus 5 dy, x terms on the right side, and that will become x e raised to power 3x. When it goes to the denominator, we can say its power becomes negative, right? If we bring it to the numerator after that, x e raised to power minus 3x dx. Now, variables are separated. We can integrate both sides. How do we integrate the left-hand side? How do we integrate this thing? Y over y plus 5? Ln rule does not work. It's not tan inverse form. Partial fraction does not work. Splitting the numerator, there's only one term in the numerator. What do we do? How do we integrate this fraction? You need to remember all the rules that we've got for fractions, right? Which rule is going to work on this? It's an improper fraction. It's an improper fraction. So we do long division. We do long division. Y divided by y plus 5. What do we multiply y by to get y? 1. So 1 into y plus 5, that gives us y plus 5. Change the signs, it becomes minus minus. This gets cancelled and we have minus 5 as the remainder. Quotient plus remainder over divisor. So the integral on the left side, quotient is 1. So integration of 1 plus integration of 1 with respect to y plus remainder over divisor. Remainder is minus 5. Minus 5 over the divisor, which is y plus 5. Integration of this separately. Now, what's the integration of 1? Integration of 1 is just y. Integration of this thing, we can write minus 5 outside. 1 over y plus 5, integration of that is going to be ln of y plus 5, because the derivative of y plus 5 is 1, so we need 1 in the numerator. We can write negative 5 outside, and that gives us minus 5 ln of y plus 5. That's the integration of the left-hand side. What about the right-hand side? That's a product. To integrate the right side, we have to use the product rule of integration, integration by parts. Let's do integration by parts on that. Use ILATE to decide between u and v dash. X is algebraic, this is exponential. So you would decide that u is equal to x therefore, and v dash is equal to e raised to power minus 3x. U dash is equal to 1, v is equal to e power minus 3x divided by minus 3, right? We are just using ILATE for this. ILATE. On the left side, we've got u. On the right, we've got v dash. The two functions that we've got are algebraic and exponential. So exponential must be v dash and algebraic should be u. Now input values in the formula. What's the formula? The formula is uv minus integration of v dash. Let me write that down here. Integration of uv dash, that is uv minus integration of v dash. Just input values in that. Now on the right side for this, u as it is. U as it is means x as it is into v, which is e raised to power minus 3x divided by minus 3, plus integration of v u dash, which means e raised to power minus 3x divided by minus 3 into u dash, which is 1. Simplify this as well. We have minus x over 3 into e raised to power minus 3x. Write this negative 3 outside, so it will become minus 1 over 3 outside. Then integration of this. How do you integrate e power minus 3x? E power minus 3x divided by minus 3. So this another negative 3 is coming in the denominator from this integration. Okay, now integration is done. At this point, you have a plus c at the same point. Okay, so once you're done with once you're done with the complete integration, right in that step, you should add a plus c. Okay, now let's simplify this further, and then we can input the values of x and y that we know. X is equal to 0, y is equal to 0. But before that, let's simplify this a little. Y minus 5 into ln of y plus 5. On the right side, we have minus x over 3 into e raised to power minus 3x plus 1 over 3 into e raised to power minus 3x plus c. Input those values. You put x equal to 0 and y equal to 0 to find the value for c. 0 minus 5 ln
1 over 9 है सर
1 over 9
right?
है. That's 1 over 9. Yes, thank you. This is 1 over 9. Okay. So good that we spotted that there. Otherwise, end पे जाके पता चलना था. Minus 5 into ln of 0 plus 5, that is equal to 0 because x is multiplying, plus 1 over 9 into e raised to power 0 plus c. Let's simplify and we get minus 5 ln 5. And then 1 over 9 from the other side. When that comes to the left side, we have minus 1 over 9. So c equals minus 1 over 9. Now we input this back there and we get that equation. What's that going to be? Y minus 5 ln of y plus 5, that is equal to minus x over 3 e raised to power minus 3x plus 1 over 9 e raised to power minus 3x plus c. The value for c is minus 5 ln 5 minus 1 over 9. They wanted a relation between x and y, some equation between x and y. They don't want us to make any specific variable the subject. Are we allowed to just leave it like this? Can we just leave it like this and say this is the final answer? Or no? What do you think? Is it okay to leave it as it is? This was considerably harder than other exams, so it was not marked. I haven't heard anything like that. Can we leave it like this? The question does not ask us to make any variable the subject, right? So is it okay to leave it like this, or should we still do something further after this? We have multiple log terms. We cannot leave multiple log terms in the final answer. We need to convert them to a single log term. That is necessary. They often have 1 mark for this in the marking scheme at the end. So make sure that you do that. Convert it to one single log term, bring it to the left side, and you can say this becomes y plus 5 ln 5 minus 5 ln of y plus 5. On the other side, you've got whatever there was. Take 5 common here, and then you have 5 into ln of, apply division law on this, 5 divided by y plus 5. On the other side, you have minus x over 3 e raised to power minus 3x plus 1 over 9 e raised to power minus 3x minus 1 over 9, and that will be your final answer. That's an equation in terms of x and y, and we have simplified the logs as well. We've converted them to a single log like this. ठीक है. That was this differential equation question, not that difficult. It was 8 marks. Okay, let's move on to the next one now. Question number 9. Question number 9. There was no partial fractions until this point, right? There was no partial fractions. Okay, let's do this. Now they're saying let I be this. Use the substitution x equals under root 3 tan u to show that. It can be written like this in this form. Now, how do we do this? They have told us exactly what to do. I is equal to integration of x cube divided by 3 plus x squared. We have to integrate it with respect to x. Limits are from 1 to 3. The substitution that is given is that x is equal to under root 3 tan u. Find the derivative of this, dx over du. What's the derivative of this going to be? Under root 3 remains as it is. Integration, derivative of tan is secant squared. So secant square u. You have to get rid of those dx from here as well. So make du the subject, and that will give you du equal to dx divided by under root 3 secant square x. Now do the substitution, see what that gives you. X cube, take cube of this number, and that will give you under root 3 into tan u whole cube. In the denominator, you have 3 plus x squared, so that will be under root 3 tan u whole squared. And then du can be replaced with this thing. Dx, no, there's something wrong. We had to replace dx, right? So we had to make dx the subject. If we make dx the subject, that actually gives us under root 3 secant square u du. That is what we would input there, multiplied by under root 3 into secant square u du. This is what we end up getting. Now everything is converted to u at this point. We can change the limits as well now. What are the limits going to be? Clearly write what the upper limit is and what the lower limit is, because sometimes they can get switched. Upper limit is 3, so x is equal to 3 and x equals 1. Now 3 equals under root 3 tan u. Tan u equals under root 3. Put this on your calculator. Tan inverse of under root 3, what's that? I think it's pi over 3, right? Please confirm this. 1 equals under root 3 tan u. Tan u is equal to 1 over under root 3. That's the same thing as under root 3 over 3. And this, I think, is pi over 6. Please confirm both of these. One is pi over 3 and the other is pi over 6, right? These are the values of u that we're getting. Now, the upper limit is still the bigger number. Lower limit is still the smaller number. So we can just input them here now. The smaller number is pi over 6 and the bigger number is pi over 3. These are the limits that we're getting. Okay, thank you. Now, we just have to integrate it now. Input limits. No, we don't have to do that yet. They just want us to show this thing first of all. Let's do that. We have to simplify it and show that it becomes this. Now you see the limits are already given here in what we have to show. So in this working, you need to make sure that you clearly are showing these steps because the answer is already given. The marks are going to be for this working. You have to show that working, okay? Achha. Now let's simplify this a little. Under root 3 whole cube and this under root 3, that will become under root 3 power 4. That's the same thing as 3 squared, which is going to be 9. In the numerator, you'll get 9 from this. Under root 3 cube and under root 3. Okay. And then we have tan cube u into secant square u. This is what we have in the numerator. What about the denominator? The denominator is 3 plus 3 tan square u. Okay, now let's simplify this further. In the denominator, what I can do is I can take 3 common. That leaves me with 1 plus tan square u. Secant square can also be written as 1 plus tan square u. So these two get cancelled. This whole thing and this whole thing, they get cancelled. 9 over 3, that is 3. What are we left with? 3 tan cube u, and that's what we wanted. That's the first part. 3 tan cube u with respect to u. Limits are from pi over 6 to pi over 3. Okay, that's our final result. That's what we wanted in the first part. Okay, now this is done. Okay, next. Now they're saying hence or otherwise find the exact value of I, give an answer in this form where p, q, and r are rational numbers. Now that's a standard part from our standard methods. Tan cube of u. How do we integrate that? Does anyone remember? Integration of tan cube. We've done this separately. How to integrate odd powers of sine, cos, tan, right? How do we do this? Integration of tan cube. Does anyone remember? We can break it down into two parts. You can break it down into two parts. You can say this is 3. We can write 3 outside as well. Tan square u into tan u. Okay. And then we used to use a substitution, right? Now you can do it using substitution as well. The substitution that we used to use was u equals tan. Now in this case, the variable is also u. So you'll have to use some other letter. I don't know, let's say y equals tan u. Have they used y anywhere? No. So you can say y equals tan u, use the substitution, and then do it using that. That is one idea. But now that we've done the extended power rule as well, we can actually make it much quicker using that. How exactly will that work? Tan square we could write as secant square minus 1, right? Because 1 plus tan square theta, we know this is identical to secant square theta. So tan square theta, that can be written as secant square theta minus 1. Let's write it like that. Secant square theta minus 1 times tan u. So supposed to be u, not theta. So in place of tan squared u, what we can do is we can write secant square u minus 1. Okay. Now, let's simplify this. Let's simplify, multiply secant square in tan u. And then we have 1 into tan u. Let's integrate that separately. Now, this tan u, how do we integrate tan u? Does anyone remember this? Integration of tan, how do we used to do that? Using log rule, right? ln rule. Tan can be written as sine over cos. So we can write this as sine u over cos u. And then this integral, that is going to become the derivative of cos is minus sine u, right? So we want minus sine u in the numerator. So what we can do for that is we can have a plus outside and put minus inside. So this integral will become ln of cos of u. So the second fraction, the second term, that is easy to integrate. What about the first one? Is there a way to integrate this? Substitution is one method, we have done that. Can we use the extended power rule in this? Can we do extended power rule? Can we use extended power rule in this? Yes or no? Yes or no, extended power rule. Yes? G, how do we integrate this? Secant square u into tan u. What can we do for this? Secant square u into tan u. Extended power rule, how do we use that? How exactly do we use that? Yes. So we'll have to do it the other way around. We'll have to rearrange it, write tan u. And then, because if we do it like this, if we say we have secant u whole squared and then tan u outside. Now the derivative of secant is not just tan, It could also be done that way, वैसे. If you want to use secant as the box in that extended power rule, you could say secant u, that is inside power 1, and then outside you have secant u tan u. Derivative of secant is secant into tan. So you could use that as well. The other idea could be that you rearrange and you write it like this, tan u into secant square u. And now you could say you have tan u power 1. Derivative of tan u is multiplying outside, which is secant squared. So the integration is just going to be tan square u divided by 2. Okay. So the integration part is done now. Once you're done with the integration, input limits are from pi over 6 to pi over 3. Okay. Pi over 6 to pi over 3. Input those limits and that will give you the result that 3 was multiplying with both of them, right? 3 was multiplying with both of them. Yes, so we have to be careful here. 3 was multiplying with the whole thing. I could write that outside the limits then. Just multiply with the whole thing at the end. Actually, let's input limits. Pi over 3. When we input pi over 3, that gives us tan pi over 3 whole squared divided by 2 plus ln of cos pi over 3. Subtract from this the case when you input pi over 6, and that will give you tan pi over 6 whole squared divided by 2 minus ln of cos pi over 6. Now, do they want an exact answer at the end? Yes, exact answer in this form. Okay, let's simplify this further. Tan of pi over 3. Put this on a calculator, tan pi over 3. Tan pi over 3 is under root 3, I think, right? Please confirm. I think it's under root 3 whole squared. We did that in an earlier question as well. Over 2 plus ln of cos pi over 3, that's cos 60. Cos 60 is 1 over 2. Minus tan pi over 6, that is under root 3 over 3 whole squared divided by 2. Minus ln of cos pi over 6. Cos pi over 6 is under root 3 over 2. You will just do this on your calculator, evaluate each one of them on your calculator, and then you simplify this now. 3 is outside as it is. Inside, this becomes 3 over 2. What do we want at the end? P, Q, and R are rational. Okay. 3 over 2 plus ln of 1 over 2. Put this on your calculator. The calculator will simplify this for you. It's going to be 1 over 6, right? Under root 3 over 3. That's 1 over under root 3, 1 over 3 divided by 2. So it will be 1 over 6. Please confirm this as well. I think it's 1 over 6 minus ln of under root 3 over 2. Okay, that's what we're getting. Now, let's move on. What's the next step going to be now? Simplify these constants. Simplify the constants. 3 over 2 minus 1 over 6. What's that? 3 over 2 minus 1 over 6. 9 minus 1, 8. 8 over 6, which is 4 over 3. 4 over 3. Okay. Plus, these are log terms. Apply division law on them. ln of 1 over 2 divided by under root 3 over 2. 2 and 2 gets cancelled. And we're just left with 3 into 4 over 3, which is 4, plus 3 into ln of 1 over under root 3. Now, could we leave this as our final answer? Could we leave this as our final answer? They told us your answer should be in this form. P plus Q ln R. P plus Q ln R, and P, Q, and R are supposed to be rational. Rational numbers are, it could be integers, it could be fractions. But you can't have square roots, right? Square roots are not rational. You know that from O levels, IGCSE as well. This is not rational. Okay, so we can't leave it like this. 1 over under root 3. How do we write that? We could write this as 4 plus 3 ln of 1 over 3 whole power 1 over 2, right? Under root 3 could be written as 3 power 1 over 2, and we could put that as a whole power like that. Now this 1 over 2 will go outside, multiply by 3, and that gives us 4 plus 3 over 2 into ln of 1 over 3. And that will be your final answer. Okay. Take 3 to the power. No, we bring 1 over 2 outside, right? That will be this form. They don't have anything as a power on top of r here. Okay. This is one way of doing this. Another possible result that you could get from this could be 4 minus 3 over 2 ln 3. That will be equivalent. If I take 3 to the numerator, it becomes 3 power negative 1, and then I can put that negative outside. So this will also be the same, right? So any of them will be correct. Now, this was a long integral, 9 marks. It's a good idea to check that. It's pretty quick, right? X cube, input that there. You will generally do this at the end of the exam, 3 plus x squared. So try to finish early so you have time for this verification. So in case there's any careless error, then you can catch that. We're getting 2.352, right? Now the answer that we are getting here, let's check that. 4 plus 3 over 2 into ln of 1 over 3. And that's the same thing that confirms that this is correct. Okay. Okay, that was question number 9, part B. Let's look at the next one now. Question number 10. Question 10. The variables x and y satisfy this equation. Haven't we done differential equations already? No, this is differentiation. Okay, not differential equation. Okay, the variables x and y, they satisfy this equation, where k is a constant. Show that dy over dx is equal to this. Now, should we take 1 over 2 to the other side as the power? Okay, no. So the derivative has 2y in it, right? The derivative has 2y in it as well. So we have both x and y in the derivative. When does that happen? When we do implicit differentiation, right? So we should do implicit differentiation rather than taking square root on the other side. That will also introduce plus minus. We will do implicit differentiation. So y squared equals k multiplied by, k is multiplying with the whole thing, right? It's with the whole fraction, you can see. It's not just with x. So k into x minus 2 over x plus 2. Differentiate both sides with respect to x. What's the derivative of the left side going to be? 2 into y into dy over dx. On the other side, that's weird. Dy over dx, they have 2y in the numerator here. Okay. On the right side, we would have to use quotient rule in this case, right? What I can do is I can simplify this before differentiating. That will be a good idea. Bring x plus 2 to this side. So we avoid using quotient rule that complicates things, right? If I bring that to the left side, x plus 2 into y squared, I can do that, right? That will become y squared into x plus 2 on the right side. So I have k into x minus 2. So before differentiating, you can actually simplify this a little. Okay, that will become easier to solve then. Now you differentiate both sides. What's the derivative of the left side going to be? It's a product. It's a product. So we use product rule on this. We can say this is u and this is v. uv dash plus vu dash, u as it is, that means y squared as it is into derivative of this. Derivative of this is 1 plus vu dash, that means x plus 2 as it is, into derivative of y squared. That is going to be 2y into dy over dx. Okay, now what about the derivative of this? K is just a constant. K is a constant, so k remains as it is. Derivative of x is 1, derivative of minus 2 is 0. So we just have k into 1 on the right side. Now we need to make dy over dx the subject. Now, notice in the final result that we want, there is no k. In the final result that we want, there's no k in that. Now, if there's no k in that, what we can do is, from this equation, we can make k the subject. And that gives us y squared into x plus 2 divided by x minus 2. And replace k with that thing. Replace k with that thing now. So we input this thing in place of k here. Okay? Now, what do we get from this? Y squared plus x plus 2 into 2y into dy over dx. On the right side, we get y squared into x plus 2 over x minus 2. Okay, so we get rid of k in the beginning. We get rid of k in the beginning. Okay. Now, we can make dy over dx the subject, take y squared to the other side, and that will give you x plus 2 into 2y into dy over dx. On the other side, you have y squared into x plus 2 over x minus 2 minus y squared. Divide by x plus 2, or you could first simplify this a little. X plus 2, if I take y squared common, that leaves me with x plus 2 divided by x minus 2 minus 1. Take LCM, y squared into x plus 2 minus x plus 2 divided by x minus 2. And now, from the other side, we have x plus 2 into 2y into dy over dx. ठीक है. Divide it on the other side. Divide this on the other side, and you'll have 1 over 2y from this side, and also x plus 2. X plus 2 and 2y. And now you simplify everything, and that will give you the result. Y squared gets cancelled with this y. In the numerator, x and minus x get cancelled. And at this point, we're getting 4y divided by x minus 2 into x plus 2, and there's a 2 outside as well. Now, 2 and 4 get cancelled to give you 2. So you have 2y in the numerator, in the denominator, x minus 2 into x plus 2, that's x squared minus 4. And that is the derivative that we were looking for. That's our final answer. That was fairly tricky. Thinking about that, you have to get rid of k like that, but that's how you do it. Makes sense, right? Any issues with this? ठीक है. इसको खत्म करें यहाँ से. If we used quotient rule, the y squared would not have been there. If we use quotient rule, y squared is coming from the left side, right? Achha, yes. If we use quotient rule, y squared would not be there in the first place. Yeah, that's also right. So using quotient rule would make it maybe slightly more efficient as well. So we would not have to take this LCM in that case. If we used quotient rule, we would not have to take this LCM ourselves. We could save another step in that case as well. Yes, that's correct. Yeah, I suppose the threshold for this is going to be actually quite low because it is a lengthy paper as well, and also some parts were quite difficult. Chale, let's look at the next one. Let's look at the next one and see what we do here. The S1 classes become really late. Chale. Given that k is equal to 5, find the angle between the tangents to the curve when x is equal to 3. Give an answer in the form A tan inverse of B over C, where A, B, and C are integers. Okay, now that we're given that the value for k is 5, we need to find the angle between the tangents, where when x is equal to 3. How do you find angle between any two lines? Remember the formula that you do in paper 1. M1 minus M2 divided 1 plus M1 M2. That's the formula that you can use here. Angle between two lines, that is given by tan theta equals M1 minus M2 divided by 1 plus M1 times M2. Now, what you need for that is the gradient of the two tangents. Gradient of the two tangents. Now, how do you find the gradient of the two tangents? We have the derivative given. We want to find the gradients of the tangents when x is equal to 3. We need the y values because the derivative is in terms of y, right? It has y in it as well. So we need to find the y values from that. How would you do that? That's straightforward now. Y squared is equal to, these are easy marks if you remember this formula. The value for k is 5. So we have 5 into x minus 2 over x plus 2. Okay. Input x equal to 3 in this. Input x equal to 3. Now when we do that, we get y squared equal to 5 into 3 minus 2 divided by 3 plus 2. 5 and 5 get cancelled and we are just left with 1. So y squared equals 1 and that gives us y equal to 1 or y equal to negative 1. We can find the derivative from both of them now. The derivative dy over dx, that was equal to 2y divided by x square minus 4. That was the derivative. Input those values. Let's find gradient of one tangent. 2 into y, that means 2 into 1 divided by x square minus 1. That will be 1, no, that will be 3 squared minus 4. 2 over 3 square minus 4, that is 2 over 5. And then we input this in the other gradient. M2, that is going to be 2 into minus 1 divided by 3 squared minus 4. What is this going to be? Minus 2 over 5. So the gradients are 2 over 5 and minus 2 over 5. Now input them in the formula. Tan theta is equal to m1 minus m2 divided by 1 plus m1 times m2. Now what does this turn out to be? Tan theta equals m1, which is 2 over 5 minus minus 2 over 5 divided by 1 plus 2 over 5 into minus 2 over 5. You'll have to simplify this, see what you get from this. 4 over 5 in the numerator, in the denominator. What's the denominator? What is the denominator? 1 minus 4 over 25, which is 21 over 25. 21 over 25. Put this on a calculator now. What do you get? 20 over 21? I'm not going to trust myself on the calculation now. Can you let me know? What is it? What this is? M1 was not leaked. M1 was not leaked. 20 over 21, right? Tan theta is 20 over 21. Now, what about the value of theta? That's tan inverse of 20 over 21. That's what we were looking for. That's our final answer. ठीक है. Any issues with this? No? Let's look at the last one now. Question number 11. We haven't seen vectors until now. So most likely, yeah. So that's vectors. Okay, question number 11. Let's do this now. Points A and B have position vectors these. Show that the perpendicular distance from A to the line through O and B is this. Now that's a standard question. Perpendicular distance, how do you find that? You first of all have to find the equation of the line through A and B. This line that passes through O and B. Okay, Aisha, I'll do that, inshallah. I'll do that. Achha. Line through O and B. O is the origin, right? So we can say OB can be taken as the direction vector of this line. We can say this is the direction vector. Let's write down the equation of the line OB. R equals A plus lambda D. In place of A, I could take the origin, right? Origin is just 0, 0, 0. That's a point. Plus lambda into the direction vector. This will be the direction vector OB. That will be 4, 2, 4. So the equation of the line OB, that turns out to be 4 lambda 2 lambda, and 4 lambda. That's the equation, right? The point is origin, so it just simplifies to this. That's the equation of the line. Now, distance from the point A. So we can make a rough sketch now. This is a line. We know the equation of the line. There's a point A somewhere. We know the coordinates of that point A and the vector for that point A as well. We have a perpendicular coming from that point A to this line. Let's call this point X. Let's call this point X. What's the position vector of X going to be? X is a point on the line. The line has this equation. Every single point on the line is going to be of the same format, right? So we can say OX vector is going to be 4 lambda, 2 lambda, 4 lambda, right? X is a point on the line. This equation represents every single point on the line. So the position vector of X should also be of the same form. Okay. Now we say AX is supposed to be perpendicular to the direction of the line. We can find the vector AX now. What is AX going to be? AX vector is OX vector minus OA vector. What does that turn out to be? 4 lambda, 2 lambda, 4 lambda minus OA. OA is 2, 2 minus 1. 2, 2 minus 1. This simplifies to 4 lambda minus 2, 2 lambda minus 2, and 4 lambda plus 1. This is the vector AX. And now we use that idea that AX vector is supposed to be perpendicular to the line. So AX vector, its dot product with the direction vector of the line, that must be 0. So AX vector dot OB vector, this must equal 0. Okay. So we say 4 lambda minus 2, 2 lambda minus 2, 4 lambda plus 1 dot OB. What's OB? 4 to 4. This must be equal to 0. And that will give you something. 4 into 4, that is 16. 16 lambda minus 8 plus 4 lambda minus 4 plus 16 lambda plus 4 equal to 0. Okay, this simplifies to what? 36 lambda minus 8 equal to 0. Can somebody please confirm this? I'm not sure if I'm doing the correct calculation. 8 over 36, is that what you get? 2 over 9? Can somebody please confirm this quickly? Is this calculation correct? I'm too tired to check this now. Yes. Okay. Lambda is 2 over 9. Lambda is 2 over 9. Now all we have to do is find this perpendicular distance, AX vector, input this value of lambda back in that AX vector. What does that turn out to be now? 4 lambda minus 2, that means 4 into 2 over 9 minus 2, 2 into 2 over 9 minus 2, and 4 into 2 over 9 plus 1. Simplify this. What do we get from this? 8 over 9 minus 2. That's minus 10 over 9. 4 over 9 minus 2. Minus 14 over 9. 8 over 9 plus 1. 17 over 9. Now let's find the magnitude. That will be the perpendicular distance, right? Square root of 10 over 9 whole squared plus 14 over 9 whole squared plus 17 over 9 whole squared. Okay, that will give you something now. 100 over, since you want to show that it turns out to be that, it's important that you show the steps now. You can add this up first inside the square root. 100 plus 14 squared plus 17 squared. You get 585 divided by 1 divided by 81. Okay. Now the denominator is square root is just 9. Square root of 585, that's 3 under root 65, and that's what you wanted to prove. This is the final result that we have. We can simplify this further. 1 over 3 under root 65. And that's the final answer. Okay. ठीक है. Makes sense. That was the first part. That was a standard part, perpendicular distance. Now we have another 7-mark question. Okay, let's do this now. The point C has position vector this. Given that OC is perpendicular to AB and angle this is equal to this, find the values of P and Q. And this is also not that difficult. It may just be slightly lengthy, but not difficult as well. OC vector, that is equal to 3 PQ. What about AB vector? Let's find the AB vector. Yeah, so you can't end up getting stuck at any question in the middle, right? So for example, we spent quite some time on one question, right? And the differentiation one. So you would probably in the exam skip that part, do the rest of the parts, and hopefully you'll get these 7 marks at least, even if you don't get those marks. Achha, AB vector, did we find that earlier? No, we did not do that. OB minus OA, that will be 2, 0, and 5. 205. AB vector from the first part, I can say that's 205. I'll just confirm that again. 4 minus 2, that's 2. 2 minus 2 is 0. And 5. 205. That's the vector AB. Their dot product is supposed to 0, so supposed to be equal to 0. That gives us 6 plus 0 plus 5Q, that is equal to 0. The value of Q is turning out to be minus 6 over 5. Okay, that's the value of Q that we're getting. So we're getting that value directly from this. OB minus OA, the J component is indeed 0, right? Okay, that's interesting. So Q value, we got that directly. The angles are supposed to be equal. Now, angle at the point O in both of them. Which vectors do we use? OA, OC, OC, OB. These are the vectors that we'll be using for that. Let's make an equation for that as well. We can say if the angles are equal and then their cos are also equal to each other, right? Cos of AOC, that should equal cos of COB. Now, that means OA dot OC divided by OA magnitude and OC magnitude. That should equal OC vector dot OB vector divided by OC magnitude into OB magnitude. Input values in this. What are the vectors? Let me write them down here. OA vector, what was that? OA from the first part was 2, 2, minus 1. And OB from the first part was 4, 2, 4. ठीक है. अच्छा, let's input them here. The dot product, OB, OC, what's that? OB dot OC or OA dot OC. That will be 6 plus 2P minus Q. That's the dot product for OA and OC divided by magnitude of OA. Magnitude of OA, let's figure that out. That will be square root of 2 square plus 2 square plus 1, right? Which is square root of 9, and that's 3. Magnitude of OB, that will be square root of 32 plus 4, that's going to turn out to be 6. Let's input that here. Magnitude of OA is 3. OC is there on both sides, right? We could just cancel that out as well. OC and OC, the magnitudes, they get cancelled, so we don't have to show that working. On the right side, OC dot OB. OC dot OB, 3 into 4, that is 12, plus 2 times P plus 4 times Q. In the denominator, we have magnitude of OB, which is 6. That's what we get. Now we can cancel this to get 2 here. Cross multiply, that gives us 12 plus 4P minus 2Q. That is equal to 12 plus 2P plus 4Q. Now the value of Q we have already figured out. We can input that here, make P the subject. 2P equals 6Q. P equals 3 times Q. Is that correct? 12 and 12 is getting cancelled on both sides, right? And then 4P minus 2Q, that is 2P. 2P equals 6Q. P equals 3Q. And that will give you the value for P as well. 3 into minus 6 over 5. And the value of P turns out to be minus 18 over 5. That is what we were looking for. Q is negative 6 over 5. And P is negative 18 over 5. That was pretty straightforward. Easy 7 marks, unless there's a careless error somewhere. But apart from that, it was fairly straightforward, right? The last part. So you see, this is happening again and again now. The last 3 papers that we did, in all of them, the last question was fairly straightforward. The last question in all of them was fairly straightforward. So you can't afford to get stuck in the middle. That's extremely important. So there were a couple of questions which were quite tricky in the middle. You would not do them in the middle. Make sure that you complete the questions first that you know about. And these are easy 12 marks at the end. A lot of people would not have reached this point. So if you get to this point and make sure that you get these marks, the rest threshold will take care of that. I don't think its threshold is going to be very high. It will be around between 50 and 53, maybe somewhere around that region for an A. So that's it. I'll see you in the next session then, inshallah. This has been a long class. We started late as well. Okay, chale. Allah Hafiz.